All right, everybody. So, for this lab, we are going to be proving whether or not F does in fact equal ma. So, we're going to be putting Newton's second law to the test, and the way we're going to do that is by using a modified Atwood machine. Now, an Atwood machine, simply put, is a machine that has a pulley, a string, and masses on either end of it, so that you can have a counterweight that lifts and can be used in multiple instances. All old windows had counterweights in them, so you could easily lift them into the air. Theater often uses counterweights to make sets easier to bring up and bring down. For electrical motors, you could use an Atwood machine as a crane and lift very heavy objects high into the sky with just a gentle push of your hand. So, a modified Atwood machine is a little bit different. A modified Atwood machine basically takes this string on a pulley with either side and just puts one end onto a table so that only one end is acting with the force of gravity. So, drawing that out, we've got an Atwood machine right here, and a modified Atwood machine. It's going to look something like this. There's my table, there's a pulley, a string, with a mass hanging off the end of the table, call that M2, and a mass on the table, and we're going to have this on a little cart, we'll call it M1. So what will happen in a modified Atwood machine is this mass will have the force of gravity acting on it, and it will pull the entire system to the right and downwards. Now see, a pulley, all it does is it changes the direction of the force. So we're going to have the same force acting on this string, pulling down and pulling to the right. So we're going to be tracking a net force, a mass, and an acceleration. The acceleration we're going to be tracking using video analysis. But the mass and the net force, we're going to have to do some thinking on how we track that. So keep in mind, as we gather data, what we're ultimately going to do with this is graph it. But we can really only graph two pieces of information at a time. So we're going to be splitting up into two sections in the class. And each section is going to maintain one variable constant in this experiment and keep one variable adjusting and see how that affects acceleration. So we're going to have one group, one section that keeps our mass constant, then adjusts the net force, and then observes how that affects acceleration. And another that keeps the net force constant, adjusts the mass, and sees how that affects acceleration. Depending on what group you're in, you're either going to make a force versus acceleration graph or a mass versus acceleration graph. And if you are one of the groups keeping mass constant, you'll make a force versus acceleration. If you're one of the groups that's keeping force constant, you'll make a mass versus acceleration, so that the changing mass is observed compared to the changing acceleration. So, what we're going to do is we're going to split you up into groups, probably 3 to 4 person groups, depending on how many people actually show up for class. Even numbered groups will be keeping a constant F net, and I'll explain how that works in just a minute. Odd numbered groups will be keeping a constant mass, and I'll explain how that works in just a minute. Specifically, and I'll cover this again in class, you'll have group number 2 will keep a 10-gram mass on the end of the string in order to maintain a constant net force of 10 grams times the force of gravity. Group number 4 will use 20 grams in the same way. Group number 6 will use 50 grams in the same way. Now, group number 1, keeping a constant mass, will keep a constant mass aside from the mass of the cart, because you're also going to have to weigh that and add that to whatever mass you have here. Group 1 will be using 405 grams. Group 3 will use 505 grams. Group 5 will use 605. And Group 7 will use 705. So, the way you're going to keep a constant mass is to recognize that when we work with something like this, we call this a system. And even though this isn't something that we're going to get to in this class, it is important to recognize that a system can be thought of as just one whole thing moving together. So the net force on this block is the net force on this whole system. So we're going to have the same net force on M1 and M2. we're not going to track this as two separate masses. We're going to track this as one mass, one system. It's just connected by a piece of string. Our total mass then is going to be our M1 plus our M2. And our M1 is going to include the mass of our cart. So, when you're keeping a constant net force, the way you're going to do that is you're going to keep the same weight on the end of this string. You're not going to change that at all, but you are going to add or subtract mass to your cart. If you are keeping a constant mass, that's going to work a little bit differently. It's going to be a little more confusing. Because you've got to keep the same mass between M1 and M2. You're going to have to keep the same thing. So M1 plus M2 must equal the exact same thing for every trial. You're going to be doing 5 trials. So the way you'll do this is you'll start with a certain mass on M2, and then you'll move mass from M1 to M2. So your whole system will maintain the same amount of mass, but sometimes it'll be in the cart, sometimes it'll be on the end of the string. And this will actually be really easy. I'll show you this in class with the weights that we're going to use, because we're going to have nicer ones than I have at home. But in just a minute, I'm going to demonstrate both ways for you. So, first off, as we go through this, we're going to be taking 5 separate pieces of information, 5 trials to gather information. We're going to have a force, a mass, and an acceleration of 1, 2, 3, 4, 5 trials. So this will get us 5 data points that we can graph. So as you're going through these trials, we're going to have an entire class period to do this, and you're going to see in my video that it really doesn't take that long to take these readings. So you're going to want to take multiple readings of each trial. The important thing with each trial is it's just going to use the same values for F and M. Okay? So you guys are going to be taking videos using your phones, and then we're going to either use software on your phone to analyze that video. We've already got some, or you can import it into Logger Pro, and you can use Logger Pro to analyze it. Okay?